We are now in the area portion of the geometry unit. We just completed perimeter, which we'll be still doing some perimeter, looking at it today, although perimeter will not be a part of this WebAssign in 12.3. If you'll look on your formula sheets, here is all the area formulas you'll be using. Rectangle and square, LW, this means length times width. Triangle is 1/2 times base times height. Circle is pi, which remember we use 3.14 times radius squared. So in today's lesson, these are the formulas you will be using. They're also in your notes. So we want to look at specifically what area is and then how it differs from perimeter. So perimeter was the distance around. The area is the measurement of the amount of surface in a shape. And the key is the labeling. This is what you have to be careful of. So many of my students incorrectly label. These are in square units, and I'll explain why they're called square units when we start looking at area. All right, so I want to look at this rectangle and this triangle down here. Now, we're going to get into area, but before we do, we're going to first look at perimeter. Now, if you remember, perimeter is the distance around. So I'm going to do perimeter in yellow. All right. So if I wanted the perimeter of this rectangle, I would add all 4 sides. Don't just add 7 plus 4. You have 4 sides. So you have 7 plus 4 plus 7 plus 4, or you have 2 sides that are 7 inches plus 2 sides that are 4 inches. So it is 22 inches around this rectangle. Now, where area is different, area is not the distance around, area is the surface. This is considered the surface. So area is going to be done in pink. So I want to know that surface. Now, here's the reason it's in square units, is because you count how many squares it takes to fill up this rectangle. So I'm going to divide the width into 4 equal parts. So if this is 4 inches, you have 1 inch, 2 inches, 3 inches, 4 inches. The length I'm going to divide into 7 inches. So here's 1, 2, 3, 4, 5, 6, 7 inches. So the reason this is in square units, and our units is in inches, so it would be square inches, is because we're asking how many squares does it take to fill up this rectangle? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22, 23, 24, 25, 26, 27, 28. So my answer is 28 square inches. But we're not always going to draw the squares and count. So this is where we use our formula. So for a rectangle, it's length times width. So I'm going to take length times width. The length is 7 inches times the width is 4 inches. 7 times 4 is 28. So 28 is the correct number, but a lot of my students will then label it 28 inches. And that is incorrect. It is 28 square inches because there are 28 squares. Now you can also write it this way. Inches squared means the same thing as squared inches. All right, so let's look at this square. So I'm going to start with perimeter. Distance around. There are 4 sides, so you can do 4 plus 4 plus 4 plus 4, or you can say there are 4 sides that are 4 inches. This is 16 inches. That's the distance around. So now I'm going to look at the area. Well, the formula for a square is the same thing as a rectangle. So this is length times width. So my length is 4 inches times my width is 4 inches. I get 16 also. You won't always get the same. Notice over here, 22, 28. It happened in this one. So what makes the perimeter different from area? It's in how you label, because the area is all of this. If I divided this into 4 equal parts and this into 4 equal parts, so I'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That's where I get 16, but it's 16 squares because there's 16 squares and our unit is inches. Or you could write 16 inches squared. All right, so there you go, rectangle, square. So now we're going to look at, and if you'll notice the formulas are right here. These are the same ones that are on your formula sheet. So now we're going to look at a triangle. And this is 1/2 times base times height. So B stands for base and H stands for height. Base times height. Okay? All right, so I'm going to come down here. Now, I'm first going to do the perimeter, distance around, so don't use the area formula for perimeter. Perimeter is at all the sides. Well, this is a equilateral triangle, which means all sides are equal. So if this is 8 centimeters, I know this is 8 centimeters, and I know this is 8 centimeters. So perimeter would be 8 plus 8 plus 8, or there are 3 sides at 8 centimeters, which would be 24 centimeters. Now, area is all of this. Now, I'm not going to create squares because once you start working with triangles and circles, it becomes a bit more difficult. So we're going to use the formula. So the area is 1/2 times base times height. Okay, so we need to determine what the base is and what the height is. So the base is the bottom of the triangle, so this would be 8 centimeters. The height is not the side of the triangle. It can be, but not necessarily so. In this case, the height is how tall it is from the base to the peak, which is 5 centimeters. So we're going to do 1/2 times base, 8, times height, 5. And so you can do that in your calculator. Of course, 8 times 5 is 40. Half of 40 is 20. And again, the big difference is you have to label correctly. Square centimeters, or you could put 20 centimeters squared. Those mean the exact same thing. All right, for the circle, now remember the perimeter of a circle is called the circumference. All right, so if I go back to the circumference, I need to determine if radius or diameter is given. And since this goes all the way across, I go, okay, 8 feet is my diameter. So since they gave me diameter, I'm going to use this formula for the circumference. So, let's see, yeah, I should have enough room down here. Circumference is pi, which remember we're using 3.14, times diameter, which is 8. So if you go to your calculator and do 3.14 times 8, you get 25.12 feet. And perimeter and circumference, we just give the units. Now I'm going to do the area. All right, the area. If you'll look here, the area of the circle is pi, but now I need radius. So the radius is from the center to the edge, which is, if you recall, the radius is half of the diameter. So half of 8 is 4. So my radius would be 4 feet. So the area which again means this portion in pink. That formula is pi 3.14 times radius, which is 4 squared. All right, I want to remind you how to do squared on your calculator. So 3.14 times 4. All right, and then your calculator should have an x squared button. When you push that, it will square that for you, and then you push equal, so you get 50.24. And since we're talking about area, it's going to be square feet, or you could put 50.24 feet to the second power means it's squared. So there's using the formula for triangle and circle. So now what we're going to do is take those formulas that we learned and we're going to apply it in these application problems, okay? All right, so this reads that we have a walkway that is 2 meters in width. Okay, this blue is the walkway. So from here to here is 2 meters. So from here to here is 2 meters, here to here is 2 meters, here to here is 2 meters, and so forth, okay? All right. The length of the building. All right, so the white portion alone is the building. All right, the blue is the walkway. The blue is not the building. So the length of the building, so the length would be, of the building, would be that right there, and it says it's 50 meters. So that's just from here to here, which means it would be the same down here. Then the width of the building, so not including the walkway, would be here and here, and that's 35 meters. Okay. Find the area of the walkway. So we want the area of the blue only. Now, there's actually 2 ways to approach this, okay? So here's the first approach. We could find the total area of the building and the walkway. All right, so I want to find the area of the building and the walkway. So what I'm saying is I want to find the area of everything. That would be everything in pink. Okay, so that area would be length times width. Now this was where you need to be careful, because if I'm doing everything in pink, the length is the 2 plus the 50 plus the 2. So the length is 54. The width is this 35, and then we know from here to here the walkway is 2 meters. So this would be 37. So to find the area of the building and the walkway together, I'm going to take 54 times 37, and I get 1,998. And this is area, so it is square meters. Now what I'm going to do is I'm going to find the area of the building only. So just this white portion, all right? And again, that's a rectangle, so it would be length times width, which would be 50 times 35. which is 1,750 square meters. Now, why did I do that? Because ultimately what I want is, I'll do this in purple now, the area of the walkway. Well, the walkway area can be found by taking the area of the building and the walkway, 1,998, and then take away the building, 1,750, and you get 248 square meters, or 248 meters squared. Now, that is one approach. As I told you, there were two approaches. So over here, we're going to do the second approach. And this is where you could just find the area of your walkway in pieces. So this, we're just going to find the area of the walkway. So what we're going to do first is find this section of blue, which this is a triangle, sorry. This is a rectangle. Length times width, this is 2, so I need to know what this side is. Well, that side is 35 plus 2, so I know this is 37 meters. So to find the area of, I'm going to draw a line right here. So to find the area of this, I'm going to take 2 times 37. And if I did this same line over here, this is 35 plus 2, so this is 37 as well. So that rectangle would be length times width, or 2 times 37 as well. So I'm going to add the other 2 times 37. Which then leaves me with, get another piece of paper, this rectangle. Well, we know from here to here is 50, and we know from here to here is 2. So I'm going to take 2 times 50 to get that area. So when I go to my calculator, I'm going to have 2 times 37 plus 2 times 37 plus 2 times 50, and I get my 248 again. So I get 248, and again, this is square meters or meters squared. So regardless of which way you approach it, you're going to get the same answer. Okay, next one. New carpet is installed in a room measuring 9 feet by 12 feet. So 9 feet by 12 feet. So that means this is 9 feet as well, and this is 12 feet as well. Now, don't let this next part, it says find the area of the room in square yards. So eventually we're going to have to do that. Okay, but let's first just take care of finding the area in feet. So we're going to calculate the area of this rectangle in feet because that's what they gave us. So we're going to do that first. Well, that area will be length times width, which is 12 times 9, which is 108. And its area, so it is square feet or feet squared. Okay, so that's the first thing that we have to do. So we found the area, this blue portion. Now what we need to do is we need to convert 108 feet squared into square yards or yards squared. Well, our formula sheet does not have the conversions for squared units. That's why they give us this right here. They're giving us the unit conversion, and you may have some of these on WebAssign. So we're starting out with 108 feet squared. If feet squared is on top, then I know feet squared goes on bottom. So I come up here, feet squared, so a 9 goes here, and that is equivalent to 1 yard squared. So we cancel out the feet squared. So on top we're left with 108 times 1, or 108. On bottom we're left with 9, and this is yards squared. Now, my guess is it's probably going to want that in a different form. I'm going to see if it reduces, and guess what? It gives me a whole number of 12. So what you would enter into WebAssign would be 12 yards squared. Okay? So you first have to find the area and then convert the units. All right, the last picture for this set of notes. So ultimately we want to find the area in blue. So if you'll notice, all of this is a rectangle, and then here we have a triangle. They tell me that the top is 6 inches. Both sides are 10 inches. And this vertical dashed line, which I guess this is a vertical dashed line as well, but this can't be 4 because from here to here is 6, so from here to here has to be 6. So that leaves this vertical dashed line 4 inches. All right, so I want the area of the blue only. So that means to find that area, I need to find the area of the rectangle, and that would be all of the blue including this, and then I'm going to subtract the area of the triangle. Okay, so I'm going to come down here and I'm going to find the area of the rectangle first. That's length times width. Length 10 times width 6. So we get 60 square inches or inches squared. Now I'm going to find the area of the triangle. And that formula is 1/2 times base times height. So I look over here and I go, okay, I'm only looking at this triangle. That forces my base to be 6 and my height to be 4. So my base is 6 and my height is 4. So that would be 1/2 times 6 times 4. You can put that in your calculator, or you can say 6 times 4 is 24. Half of that is 12. And it's area, so it's square inches or inches squared. So now I'm going to take these two numbers and come back up here, because this is the area I'm ultimately looking for, that is in blue. And I'm going to take the rectangle minus the triangle, and I get 48 square inches or inches squared. So this is the final answer that we are looking for.